Okay, this is 7.1c in college algebra, and we are continuing on. We're in sigma notation right now. In sigma notation, sigma is a Greek letter that looks like this. Okay? And some people call it a summation symbol or a summation notation, but that's what the symbol looks like. And let's say, for example, I have 4 on top of that, and I say k equals 1, and I have 2k plus 1. Okay, so there's sigma notation. And that all means something, okay? And it's really not very hard. This k is called the index, and it can be a k, it can be an x, it can be a z, any letter at all. It doesn't really matter what letter that is, as long as this letter and this letter are the same. Because what this is telling you is that we are going to start with the number 1, and we're going to end with whatever number is up here. So if this says we're starting at 1 and we're ending at 4, and we're going to put a 1, 2, 3, 4, okay, a sequence. We're going to take a 1, 2, 3, 4 and put it in here for k. So what we're going to, and then we're going to add those. So we start out with 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1, and 2 times 4 plus 1. Okay? And that's what this sigma means. We start at 1, and we go 1, 2, 3 in a numerical order all the way to this number, and we just put those numbers in here like we did here, 1, 2, 3, 4. Find our answers. So this one is going to be 2 times 1, that'll be 3. This will be 5, this will be 7, and this will be 9. So we take 3 plus 5 plus 7 plus 9 and get 24, if I did my math right, 15, yeah. So the answer to this is just going to be 24. Okay? So it's a little bit of effort, but gosh, it's not really hard stuff. Okay, so let's jump to example 4, problem A. We've got 5 on top, and we've got k equals 1, and we're cubing it. So we've got 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. And we're finding that answer. Okay? So you're adding all those up. All right, B says that we're at 4. Our k is 0. And our formula is negative 1k, 5k. So that's going to be negative 1. And what are we starting with? 0. Negative 1, 1, 5, 1. Negative 1, 1, 5, 2. All the way up to 4. And then you add these up. Okay, so negative 1 to the 0 power times 5 to the 0 is 1. This is going to give me a negative 5 plus 25, and then plus, all the way till 4. So we're going to start at 0, and we're going to go up to 4. So we're going to have 5 parts that we're adding, because 0, 1, 2, 3, 4 is 5 different parts. Okay, so that's that one. Let's look at one that's a little bit harsher. Let's look at C. We have 11, summation, I equals 8. So remember, it doesn't have to be a K. It can be any letter at once, as long as when you write the general term down here, it also includes this same variable here. Okay, this can't be an X and that's an I. All right, so we're starting at 8. So we have 2, and then we go to 9, and then we go to 10. And that's where we stop because of the 11 right there. Okay? So 8, 9, 10, and 11. Add all those up, and you end up with 8 and 1,691 over 3,960. So you add 2, 4, 6, 8, but then when you add 1/8 plus 1/9 plus 1/10 plus 1/11, you get a stinking common denominator of 3,960. So anyway, that is example 4. Let's look at 5. Okay, so for example 5, they're giving us this here and saying, come up with the sigma notation. Well, the easy part is this part. And I can look here and go, okay, 1, 2, 3, 4, 5, 6, 7. There's 7 numbers there. So the difference between where I end and where I start is going to be 7. Okay, that doesn't really help me a whole lot. But let's just see what happens as I go from each of these numbers. Now look here, if I square 1, I get 1. If I square 2, I get 4. Okay, that doesn't help me, does it? Okay, what would happen if I had 2 to the 0 power? That gives me 1. Okay, so see what happens here? My numbers have to be counting numbers. Okay, and this one I started at 0 because 2 to the 0 power is 1. 0, 1, 2, 3, and that would be 4, and this would be 5, and this would be 6. So I started with k equals 0. I started with this one, and I ended up with a 6, which is a difference of 7, because, you know, you start with 0, so 0, 1, 2, 3, 4, 5, 6. There's 7 numbers there. But what is my formula going to look like? Well, my formula is going to be 2 to whatever, whoops, not a k, it's got, or an n, it's got to be a k, doesn't it? So does that work? 2 to the 0 plus 2 to the first plus 2 squared all the way to 2 to the 6th power. Okay, and it does. So that's the one that I want there. All right, so let's look at the second example. Come on, get rid of some of these numbers. I wish I could just erase everything in one fell swoop, but I can't. All right, -2, whoops, plus 4 minus 6 plus 8 minus 10. Okay, so one of the things that I know here is that I'm going to have a -1 to the k power because of my alternating. And I don't know what my k is equal to yet, where I start, and I don't know where I finish, but I do know I have that -1 to the k power because they switch back and forth. All right, so the sum begins with so I've got 5 numbers that I'm looking at here, right? Okay, so I've got to be able to get to -2. So if this is a 0, if this is a 0, that means that's 0, and -1 to the 0 power would be +1, because anything to the 0 power is +1, so I won't be able to get a negative there. So I know I can't start at 0. So I know I have to start at 1, because -1 to the first power gives me my negative. So that helps. And that also tells me that I'm going to end at 5 then. So how do I get this 1 to be a 2? Well, if I take 2 times 1, or 2 times whatever k is, in this case it's going to be 1, I end up getting -2. Now let's see what happens if I put a 2 in here. That gives me a positive, And what happens if I put a 2 here? 2 times 2 is 4. This is positive, gives me a 4. Okay, let's see if I put a 3 in here. A 3 there gives me a negative. A 3 there gives me a 3 times 2 is 6, gives me a negative 6. Okay, is this too abstract? Do I need to actually show this? Negative 1 to the first power. Okay, negative 1 squared. Negative 1 cubed. Negative 1 to the fourth. Okay, so this ends up being the formula I want in order to make that work. Okay, and I'm going to skip C. Getting into these fractions, I don't think I gave you any of those in the homework, but just, use your book and play around with it. I'm not expecting this to come really quick and easy the first time. All right, last part of this is recursive definitions. All right, so a sequence may be defined recursively or by using a recursion formula. Okay, so what they've given us is the first term. Sometimes they'll give us several of the terms, the first, second, third, fourth term. Then they'll give us a formula to describe how to get the remaining terms. And let me change this. This is a plus 1 here, not up there. Okay. And they'll ask you to find, such as example 6, the first 5 terms of the sequence. So they're asking us to find all 5 of these terms. All right, so let's start with 1. They gave us 1. They said it was 5. Okay, so what they're saying here on A subscript 2 is we are going to take 2, all right, A to the n plus 1 means this is our previous one, this is our beginning one, and adding 1 means we're going to the next one. So when you see an n plus 1, it means you're going to go from here to here, and then the next n plus 1 is whatever this is. 2 plus 1 would give us our 3, and then our 4, and then our 5. So that's what that n plus 1 means. So we've got 2 to the A first minus 3. Okay, so we're using this formula here. And that equals 2. What is A to the first? 5 minus 3 equals 7. 10 minus 3 is 7 there. Okay, so the A3 would be 2A the second minus 3. So what is A to the second? A to the second is 7. And the next one would be 2A cubed minus 3, which equals 2. What is the third one? 11 from up here, minus 3. And this last one would be 2A to the fourth minus 3 equals 2. Whoops, this is supposed to be 19, right? 2 to the times 19 minus 3 equals 35. So those are the first 5 terms of the sequence. Alright, so the key thing I want you to get here, because sometimes this gets confusing. This is saying A to the n plus 3, A to whatever n is, plus 1. Okay, so A to the, if the n is a 1, then when you get down here, this is a 1 plus 1 is 2. And then we take 2A to the n, which is the previous one, okay, because this one's A to the second, because we added 1, so that means this would be first. And then you take your number from the first one. If we're down here to the, let's say the fourth, it's going to say, okay, A to the fourth would be the previous one, without adding the 1 to get the 4. So this would be A to the third. So we go to the answer to the third one and we plug it in here. Okay, and so on and so on.